Okay, so we were talking about alkanes in the last class, and we were talking about combustion in the last class, right? Now I just want to show you one journal equation for the combustion of hydrocarbons, right? The journal equation for the combustion of hydrocarbons. This is for all hydrocarbons like alkane and alkene and whatever you have. This is the journal equation. For example, whatever the hydrocarbon you have, the number of carbon and hydrogen not matter, right? Oxygen always balanced by this way. This is a way to balance oxygen, right? And carbon dioxide molecules are always equal to the number of carbons present in the molecule. And the water molecules are always half of the hydrogen atoms present in the compound. For example, if you have C5H12, you can see this. We have 5 carbons and we have 12 hydrogens, right? And then we have 5 carbon dioxide and we have 6 water molecules. And this is 4 1 the 4, 4 3 the 12. It is 8 oxygen molecules, right, Bacho? This is a journal equation to balance the combustion of hydrocarbons. Okay, Bacho, is that clear?
Yes.
This will help you in the calculation as well. Many of the questions will give you the unknown hydrocarbon and they give the volume of oxygen used and the volume of carbon dioxide produced. So you can find out the values of this and then you can find out the hydrocarbon, right? So I have one question about this. Let me see the question. I think I have. Was the question. But do you have physical past papers?
No.
Okay. You should have the past paper booklets now, because if you practice past paper questions, it will be great for you. Now, where I find this, I have a lot of folders in my mobile phone. Yes, I think over here. Yes. Okay. Where is the question? Combustion reactions. Okay, but so I am finding some questions for you, but due to a lot of pictures over here, it is difficult for me to find out the question. The question. Okay, so I will find out this and then I will solve you in the next class, inshallah, right? We will do some questions like past papers in the next class if you want, or you can even complete the syllabus and then we will do some past papers question. Whatever you say, we will discuss that accordingly. But over here, it is difficult for me to find out. I don't know where is the question. Okay, so let's move on. For example, we will move towards the next chemical property, which is free radical substitution reaction. But so this is the most important chemical property of this chapter. A lot of questions about this is in the past papers, and almost after every year, you will see the question of this topic in the paper. It is very, very important, right? So whenever you talk about free radical substitution, you need to be very conscious about this topic, because it has a great value in the question papers of final exams, right? So what is free radical? First, we talk about what is free radical and what is substitution. Then we will talk about the process. First of all, you need to know about the meaning of free radical, and you should know the meaning of substitution. These two words should be very clear for you. Then we are going to talk about what? The process, right? So what is free radical? The free radical is actually, for example, you have a chlorine-chlorine bond, right? We know that chlorine has 7 electrons in the outermost shell, right? So it requires one more electron to complete its octet. So it share 1 electron with the second chlorine. In this way, they've just completed their octets, right? When, for example, the amount of energy is absorbed by this bond breaks, right? When this bond breaks, this electron will back to the chlorine atom. This electron will back to the chlorine atom. Now you can see this. When both of them move back to the chlorine, they will be like this, right? They have already 6 electrons, and these 6 electrons are already in pair, right? This pair, these six electrons are already in pairs, right? The only 1 electron is unpaired, right? So I'm just going to show you the unpaired electrons, right? We are not showing the paired electrons over here. We are just going to show unpaired electrons. Now, you need to remember this, Vacho. What is free radical? Free radical is actually what? This is unpaired electron. This is unpaired electron. And it is highly reactive. It cannot leave alone. It is highly reactive. It wants to react with anyone. Whatever the way to react, it definitely react with anyone. For example, if sodium is near, so it will receive 1 electron to become chloride ion, or if any non-metal is there, it will share that electron to become a covalent bond over there. In any case, this chlorine free radical must react. This is highly reactive. This is unpaired electrons. You need to keep remember this definition for 1 mark in exam, right? Then one more thing over here. This is the bond breakage, right? This is the bond breakage. There is a type of bond breakage in our syllabus. This is one of the type, and this type is known as homolysis. This is homolysis, or you can call this as homolytical fission. This is homolytical fission as well, right? So what is this? This is actually the breakdown of a bond. This is actually breakdown of a covalent bond. Yeah, any bond. It is actually a breakdown of a covalent bond, right? When the bond breaks and the electrons present in that bond equally distribute between the elements, right? And electrons share equally. Electrons share equal, right? You can see this. We have 2 electrons over there in the bond. When this bond breaks, 1 electron moves towards this chlorine, 1 electron moves towards this chlorine. This is equal distribution of electrons. When the distribution of electrons is equal, that means this is homolysis or homolytical fission. This is one of the type of bond breakage. We have one more type of bond breakage, which is hydrolytic fission, but we will talk about this in the next chapter, right? And what is substitution? Substitution is when, for example, you have a methane molecule. When you reacted with chlorine, you will see this. 1 chlorine will displace 1 hydrogen. This is actually the substitution. When 1 atom take place, the second atom. This is a bond right now like this, methane molecule, and you are reacting it with chlorine molecule, right? So you will see that this chlorine takes the place of hydrogen, and this hydrogen takes the place of this chlorine. So you will see that it will be like this. It is like this. So this is actually the substitution reaction, right? So you need to understand the meanings of these words. If you know the meanings, then definitely you can understand the whole procedure, right? So first of all, what is free radical? Free radical is actually the unpaired electrons, right? And what is substitution? Substitution is the replacement of any atom by another atom, right? And we need to understand this topic is actually free radical substitution. So whatever the substitution take place in this reaction, it is just because of the free radical, right? And how free radical forms? The process is homolysis, or you can name this as homolytical fission, when the bond breaks and the number of electrons between in the bond is equally distributed between the two atoms. So this type of bond breakage is actually homolysis. Is that right, Bacho?
Yes.
Now let's move towards the main topic, which is free radical substitution. Now we are moving towards the free radical substitution officially, right? Free radical substitution. Actually, free radical substitution is one of the very important and very interesting topic of the organic chemistry, and it is completely separated by any other topic. It is completely different, right? So you need to remember this. Right now we are talking about what mechanism, how this reaction is going to be happen, right? This is mechanism. This is one of the mechanism of the organic chemistry, and I am just showing you this is first mechanism, right? We have 4 different mechanism in the whole organics syllabus. This is the first one, right? So remember, whenever free radical substitution reaction occur, it will take places in 3 different states, right? We have 3 different steps for the free radical substitution reaction. Number 1, initiation. Number 1 is initiation, which means the reaction is going to start from here. And then propagation, the reaction is going to continue in this process, propagate, the reaction is going to propagate over here. And in the last, it is termination, the end of the reaction, right? So actually the problem is this. In the first, you need to understand this, we generate free radical. We generate free radical. We know that free radical is highly reactive. So we are going to start the reaction. So we need to generate the free radicals, right? So this is the first process, what you need to understand over here, the free radical is going to be generated. And then in second one, it is a reaction due to free radical. Free radical is actually highly reactive, so it will generate some reactions over there, and it start propagating the reaction, right? And the end, you are terminating, or you are just finishing the free radical. When you remove the free radical from the process, you will see that the reaction is going to be ended, right? So these are the 3 steps that you need to understand in this process. You need to go through this. And right now we know that we are talking about alkanes, right? We are talking about alkanes because this is a chemical property of alkanes, right? So one of the reactions should be alkane. Then the second one is halogens, right? This is a reaction of alkanes with halogens, right? You need to remember this, that you can use chlorine or you can use bromine over here, right? And must remember the condition over here is UV light. Without UV light, this reaction is not possible, right? So the essential condition for this reaction is UV light. This is very important for 1 mark as well. You need to remember this. It is also for 1 mark, that the essential condition for this reaction is UV light. Without UV light, this reaction is not possible, right? So UV light is very important for this reaction, or even you can supply the such energy which is actually the equal to the UV light. So if you provide such energy, so it can also happen, but UV light is main, right? Now let's start the reaction. For example, I am reacting, or I am having methane gas with chlorine gas in a container, right? For example, I have a container. I have a container. I have this container. For example, I have this container, and this container is actually closed. This is closed container, right? And I just take methane gas over here. For example, this is a methane gas. This is methane gas over here. And also I have chlorine gas over here. So the color of chlorine gas is obviously different. So let's have green color over here. Chlorine is greenish yellow. So it is a chlorine gas, right? For example, these two gases are over here together. And from outside, we have a sun, right? Outside. So this sun is actually putting some UV lights over here. So when the UV light comes from sun, strive over here, so it start reaction over here, right? They start reaction over here. So initially there is first reaction, which is actually what? Which is actually initiation. First of all, there is initiation, right? In the first step, initiation, you will see that what happened, the chlorine molecule receive UV light energy and break down into free radical, right? You can see this. Two free radicals generated, right? The chlorine molecule or the chlorine bond breaks homolytically, right? And it generates free radicals. And we know that free radicals are highly reactive, right? And we just have two things in the container, methane or chlorine, right? Then the reaction is going to be start, propagation, right? The propagation, what is the first stage? The first stage. The first stage is what? You just have two things inside the container. You have methane, you have chlorine, right? We have two substances, two reactants in the container, right? And due to the sunlight, few chlorine molecules break down and they form what? Chlorine radical. And the chlorine radical is highly reactive. It is highly reactive. So it reaches methane and it also reaches chlorine molecule. Just look at over here, the reaction with chlorine. For example, chlorine radical reaches to the chlorine molecule. It just take out the chlorine, one of the chlorine from chlorine molecule, and again react with it to form chlorine molecule, and the remaining one will be chlorine radical. This will be the reaction if chlorine radical attack on the chlorine molecule. So in the chemistry, if the reactants and products are same, in chemistry, if the reactants and products are same, that means there is no reaction, because the bond energy which is actually released or absorbed in this overall reaction will be same. When both energies are same, that means reaction is not possible, right? So that means the free radical over there, which is actually chlorine, if attack on chlorine molecule, there is no reaction, right, bacho?
Yeah.
Okay, so you need to remember this. If the reactant and products are same, then there is no reaction. Now, chlorine radical just have one more space over here. And what is the space over here? That chlorine radical can attack methane molecule. And there are two possibilities. What are the two possibilities? The two possibilities are methane molecule we have, right? In the methane molecule, we have four different bonds with hydrogen, right? Like this. So for example, chlorine radical comes and just remove this H from here, right? And it will form what? Free radical to the methyl group, right? And the eliminating H will react with chlorine radical and form HCl. This is one of the possibility. And the second possibility is that methane molecule is on its place and chlorine radical attack on this, and it removes H from here and just take a place of that H and form H radical over here, right? These are the two possibilities that chlorine free radical can do with methane molecule. Is that right, Bacho? Is it right, Bacho?
Yes.
Okay, so my application is hanging today. I don't know why, due to the load over here. Now I think it is hanging. So we have two possibilities over here, that methane can be attracted by chlorine free radical, and it can form methyl radical or HCl. Or the second possibility is this, that methane molecule is attracted by chlorine radical, or hydrogen is removed and chlorine just take place of that hydrogen. We have these two possibilities. And remember, bacho, in the whole chemistry, the exothermic reactions are more feasible, right? So this is the exothermic reaction and this is the endothermic reaction. So this cannot be processed. The only possibility is this, right? So that means in the first stage of propagation, the very possible reaction is this, that chlorine
Sir, how
radical.
will we know that a reaction is exothermic?
But you can find out the bond energies, and you can use bond energies. You will understand this. The bond energies are given in the data booklet. You can use the bond energies of this reaction. You will see that it is what, right? Okay, but
Yes.
this by your own as well. And many of the teachers just told you that just remember this, just remember this. I don't want to tell you that you just need to remember this. I want that you will do this by your own, so you understand the chemistry behind this, right? So you need to generate a chemist in yourselves, right? So the main thing is this, that if you have methane, the only possibility is this, that when chlorine radical attack on this, it will form methane, a free radical, and HCl will form, right? This is the very perfect or the feasible reaction over here in the container, right, Bacho?
Yes, but I have one doubt, sir. Why wait, why doesn't the Cl2 have a free radical? Oh wait. Acha, never mind. Okay, I understand.
We have a lot of molecules in the beaker, na? A lot of molecules of chlorine over there. So maybe uh, 5 of them or 10 of them or 25 of them become a free radical. Not everyone over there will be the free radical. Maybe 2, 3, 4, many more molecules of chlorine are going to be free radical. And a free radical is actually highly reactive, which is going to start the reaction, which is going to propagate the reaction, right? That is why methane is neutral molecule. It is not going to react with anyone else. It already have 4 bonds with hydrogen, right? But chlorine becomes free radical, which attack on this and then start the reaction, right? So where the
Yeah.
feasible reaction is this, that methyl radical forms and HCl form, right? This is the exothermic reaction. That is why more feasible over here. So this reaction happens. But again, you can see this methyl radical form, which is also a free radical, and it is also highly reactive, and it also have unpaired electron. So now it start roaming around to find someone to react. So it will attack on chlorine molecule, which is Cl2 over here. And we know that CH4 is also over there in the beaker, in the container. But if CH3 attack on CH4, the same products and reactions are formed, which is not the possible reaction in chemistry words. So it will form what? Now a chlorine is attached over here. Now you just look at over here, so this is the first stage. You need to remember for the second stage. What you need to remember, that chlorine radical is attacking in the first step, right? And it is removing the H from methane, one H, and it becomes free radical, and HCl is most product, right? And in the second step, this free radical, which is formed in the first step, attack on chlorine molecule, and now a chlorine is going to add over here, right? And it forms chlorine radical. The same as it is will be followed in the second step. Now, we know that in the container, we have a lot of molecules of CH4. We talk about this, that chlorine radical can attack on methane molecule, and this process can be done, right? But the first stage is done. Now, let's talk about the second stage. When you talk about second stage, I'm gonna delete this. In the second stage, what is going to be happen over there in the second stage. Just see this. We have one more new substance which form over here is CH3Cl, right? This is one of the new products in the container, which is also in the container, right? So now chlorine radical can even attack on this as well, right, Bacho? In the start, we just have methane molecules. So we need to understand that chlorine can attack on methane and it just remove one H over there and form that methane a free radical and then form HCl, right? That's fine. And then methyl radical is highly reactive, then it reacts with chlorine and forms CH3Cl. Now in the same container, we have one another molecule or one another product which is formed. Now the possibility is this, that chlorine radical can attack on this as well, right? So now chlorine radical attack on this, again remove one H and make it a free radical and form HCl. It is fixed. It is always form HCl, and if bromine is over there, so it will form HBr, right? And now this radical is highly reactive, so it will attack on chlorine molecule, and in this step, chlorine is going to be added, right, Bacho?
Yes.
It is same for the third stage as well. You need to see this, that we have one more molecule, one more new substance over here by which chlorine can react. So chlorine can again attack on this molecule as well. This is also the possibility once it formed in the container. So it also remove the H from this, and again HCl is one of the main products. Then this free radical is also highly reactive due to unpaired electron. So it will react with chlorine or attack on chlorine and attach or add one more chlorine into it. Right, Bacho?
Yes.
And the last stage is, in the last stage, you will see that, Bacho, you will see that the only H is also going to remove by the attack of chlorine. Now chlorine radical attack on this and remove the only H from here and form it a free radical again, and HCl molecule as well. And now this highly reactive free radical due to the presence of unpaired electron attack on chlorine molecule, and in the fourth step you will see that CCl forms, right? अब यहाँ पर आपके पास CCl बन गया. You can see this CCl is actually having no hydrogen. Now chlorine radical cannot replace any hydrogen from this molecule because है ही नहीं, है ना बच्चों? Is that right?
Yes.
This is actually propagation. This is what? This is actually propagation, बच्चों. ये propagation, you can see this. The propagation is actually due to the presence of free radical. Just look at over here, initiation and propagation. In the start, I told you that initiation is actually generating a free radical, right? So you can see this over here on the reactant side, there is no free radical, but the generating of free radical is actually the process known as initiation. We generate free radical, right? And the whole reaction after this is due to the presence of free radical. Just look at over here. There is a free radical, right? When free radical reacts with a neutral molecule, over here the odd number of electrons are there. Now there is no even number of electrons. When there is no even electrons, definitely no neutral product is going to be formed. So when you react molecule with a free radical and molecule form. Again, free radical molecule, free radical, free radical molecule, free radical molecule, free radical molecule, free radical molecule. You can see this, and every reaction, why the reaction is going to be propagated, because in every step the one of the product is free radical. Whenever you react free radical with a molecule, it must produce one free radical and one product. So until and unless you are going to remove this free radical, the reaction is not going to be stopped. So the whole propagation process, the whole continuity of the bonding over here and the reactions over here is just because of the presence of what? Free radical. So free radical is actually the reason why the propagation is going to be processed. In the product side and in the reactant side, you are finding a free radical over there. In the initiation, you just find out the free radical on the product side. But in the propagation, you are finding free radical on both sides. So what we need to do to stop this reaction? So if we want to do the stop of this reaction, or if we want to do a termination of this process, so we must need to remove free radicals from there. So termination is actually the process to end this reaction or the free radical propagation. So what we need to do in the termination, we just need to react two different free radicals together. Once two different free radicals join together, the odd electrons are going to be even. Just look at over here how many free radicals we have. Just look at over here how many free radicals we have. A chlorine radical, a methyl radical, CH2Cl radical, and a CHCl2 radical, and a CCl3 radical. So we have 5 different radicals in the process, right? Any one of them can react with any, right? So we have chlorine radical, we have CH3 radical, we have CH2Cl radical, we have CHCl2 radical, we have CCl3 radical, right? These are the 5 free radicals present in that the whole container of the vessel. So they can react with any one of them. Even for example, chlorine can react with chlorine radical, so it will form chlorine molecule. It is a neutral molecule. Even chlorine can react with CH3 radical, so it will form what? CH3Cl. Even chlorine can react with CH2Cl radical, and it will form what? CH2Cl2. Even chlorine molecule, free radical can react with CHCl2 radical, and it will form what? CHCl3. Even chlorine radical can react with CCl3 radical, and it will form what? CCl4. So any two radicals can join together to form a neutral product, and this is actually termination of the reaction. And one more very, very important thing is you need to remember this: we are doing a reaction of methane with chlorine. We are doing a reaction of methane with chlorine. So for example, during the process, a methyl radical reacts with a second methyl radical. So you need to remember, bacho, over here, ethane can be produced. We are doing the free radical substitution reaction of methane, and during this reaction, ethane can also be processed. Ethane can also be produced. So this is the overall process in the same container. The whole process is in the same container. Now, all the reactions are going to be here, doing over here. So for example, if ethane molecule form inside and chlorine radical attack on ethane molecules, you need to understand this, that the free radical substitution of ethane can also be processed or can also be started over in the same container, right? Because these reactions are all having at the same a chlorine radical attack on methane molecules. So for example, a single reaction occurs. So right now you have 99 molecules of CH4 remains and 1 molecule of CH3Cl form. Now, when the reaction is going to be processed, the methane concentration is going to be decreased and the other molecules concentration are going to be increased. So every reaction will be processing over there, right? Every reaction, but with the different rates. Definitely the number of molecules of that product are present over there different. So they are reacting according to their number of molecules. Is that right, Bacho? Yes, Bacho, is that right? Now let's talk about one question in the past paper. I saw multiple questions of this topic in past papers. Let's discuss one of the questions. Let's discuss one of the past paper question over here. Let's discuss. For example, in the question, they are saying that you have ethane molecule and you have this reaction. They just gave us the complete reaction. They gave us that you have alkane, which is C2H6, reacting with chlorine and forming what? C2H5Cl plus HCl, right? They ask the mechanism of this reaction. They ask for the mechanism of this reaction. And I think it was a question for 5 marks or 6 marks. I think so. I'm not exactly remember the marks of this, but it is almost 5 or 6 somewhere. It is a very important question for 5 to 6 marks, right? So they are asking for the mechanism of this reaction. You can see this. This is actually what? Ethane, which is alkane, whenever any alkane is going to react with halogen, you need to remember this, that UV light is very important for this reaction. And halogenoalkane form. This is halogenoalkane. Halogenoalkane means alkane with a halogen, right? So this is halogenoalkane form with HCl molecule. So this is the reaction that you need to understand, right? And they're asking for the mechanism, that how this process and how it forms, right? You just need to remember what you need to do this in this process. Just write down the heading of initiation, right? And show the reaction of this. Initiation, a chlorine molecule over there. When UV light attack on this molecule, it will form free radicals, right? This is the first thing that you need to write in the answer. Then propagation, just write down the heading of the step. It is very important. It will award you 1 mark for this, all right? And a chlorine radical attack on this molecule C2H6, right? And we know that it will remove one of the H atom from there and form it a free radical, and HCl molecule form. This will give you 1 mark. And then this free radical, highly reactive free radical, attack on chlorine molecules and add chlorine in it, right? This will give you 1 mark as well, right? You can see this, they are just asking for this reaction, right? They are asking for just this reaction. So we are not going to propagate our propagation, right? We are not going to propagate. They are asking for this reaction, right? Right, bacho? So that's enough. They are asking for this product, and this product is from the asking product is C2H5, and just we do this for this, right? We did this, right, bacho?
Yes.
Then termination. It's all up to you. What is the reaction of termination that you want to write? You can write any termination reaction. For example, you can write chlorine radical reacting with chlorine radical forming chlorine molecule. You can even write chlorine free radical can reacting with C2H5 molecule to forming C2H5Cl, or you can even react C2H5. You can even react C2H5 free radical with C2H5 to form butane molecule, right, bacho? Any one of them is acceptable, right?
Yes.
It will give you five marks or 6 marks, I think. So you need to remember this: 1 mark for this, 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 and 1 mark for this. I think it is 1, 2, 3, 4, 5, 6 marks question. Is that clear, bacho?
Yes.
They can even ask the essential condition. They can even ask the essential condition of this reaction, and it is also going to award you 1 marks. And the essential condition will be asked in a different part, so it will also give you 1 mark as well. They can even ask for the type of reaction as well. They can even ask for the type of reaction as well. So, but your type of reaction, we know that we are talking about free radical substitution reaction, right? We are talking about what? Free radical substitution reaction right now. So this is the type of this reaction. So if they ask about the type of reaction, so you can say that this is free radical substitution reaction. This is free radical substitution reaction. Is that clear, bacho?
Yes. Yes.
Any problem? Okay, so let's move one more example. I have one more example for you. And for example, they are saying that they are just giving you a block over here, right, like this. A block like this, and we have different things over here, like they are saying the step, name of the step, right? For example, the name of the step, right, and the reaction. Name of step and the reaction over here, right? For example, just gave us one reaction over here. They are saying that you have this this molecule, and this going to convert into this molecule, right? So initially they gave us few things like they just gave us bromine molecule, and due to the presence of UV light, it is break down into bromine radical, and they're asking for the name of the step, right? And for example, they are giving us, right, this bromine radical attack on this molecule, right? When this attack on this molecule, they are saying that this is a skeletal structure of one of the hydrocarbon. They are saying that the hydrogen removed from here and one of the molecule from over here, and this is propagation, right? So you need to complete this, and then in the next step, they're just asking for the step, and they are saying that this free radical is going to attack on bromine molecule and attaching bromine over here on it, right? And forming what? Bromine radical. And the last step, they are asking for the name of the step, and also they are showing you what? A free radical of this hydrocarbon with a free radical of bromine, and also asking for the main product. Yes, Bacho, can you solve this? Yes, every one of you, can you solve this?
I'm trying.
Okay, let's try. Let's try to solve this and send me the picture so I can check. Okay, and the last chemical property is actually cracking. The last chemical property, which is the third chemical property, I told you earlier that this is not the specified chemical property of alkanes. I'm just going to consider this a chemical property, so I can do this right now in the chemical properties. Okay. Okay, bacho.
Yes.
Okay, so cracking is we have two different possibilities of cracking. The first possibility is whenever any alkane is going to crack, it is going to form what? Alkene and alkane, right? Alkene and alkane, right? And for example, it is one of the other possibility that if alkane is going to be breakdown, it is forming alkene and hydrogen gas as well. We are two different possibilities, or any one of them would be correct if you write, right? There would be some hints as well in the question, so by which you can write the equation as well for cracking. The important things to remember is conditions. You need to remember the conditions for the cracking, and the conditions are actually catalysts. You can use the catalyst over here like silicon dioxide or ammonium oxide, along with the temperature. The temperature is very important over here. 550 degrees centigrade to 600 degrees centigrade temperature would be applicable over here, right? This is the scene over here, and the importance of this process is actually it is used to manufacture alkenes. The one of the very important thing is it is going to prepared alkene, right? So you can say that manufacture of alkene due to this process, right? Then secondly, you can say that this is actually manufacture of hydrogen gas. You can say that you can produce manufacture of hydrogen gas by this process, right? Or you can say that formation of shorter hydrocarbons, formation of shorter hydrocarbons as well. Shorter hydrocarbons are actually more useful, and the demand of shorter hydrocarbons are greater, right? Due to the greater demand. This process is due to important. Right, Bacho?
Yes.
Now the problem is this. For example, if I have C6H14, this is one of the alkane, right? For example, if I am going to heat this and I'm going to use catalyst over there, so we know that one alkene can be formed and one alkane can be formed. That's fine. The equation is correct, but the equation can be like this: alkene this one and alkane this one. This can be the equation. Equation can be like this: this one is alkene and this one is alkane. Equation can be like this: this is alkene and this is alkane. right? Equation can be like this. We have C5H10 and CH4 as well. Equation can be like this, that we have C6H12 and hydrogen gas, or we have 3 molecules of C2H4 and 1 hydrogen molecule. So you can see this, Bacho, that is in a single molecule which is having only 6 carbons, can have more than 6 or 7 possibilities, right? So that is why there is always a journal hint for you in the question, by which you can write the equation, the correct equation, right? For example, a examiner asks you to write the equation in this way. For example, they say that you have a hexadecane which is going to crack under 500 degrees centigrade or 550 degrees centigrade or 600 degrees centigrade using silicon dioxide as a catalyst, right? Hexadecane is going to be cracked, right? And they just use one hint over there, and they will say that one of the unsaturated product will form, one of the unsaturated compound form, with 6 carbons, 6 carbon atoms. Now you can write the equation, right? Hexadecane matlab hex 6 or dec matlab 10. So they are saying 16 carbon. So they just gave you the formula for this as well, because hexadecane is not in our syllabus. So C16H38 is going to be breakdown, and one of the product which is unsaturated having 6 carbons. So this is C6H12. This is fixed. Now the rest of the molecule is all depend on you. If you write over here like C10H H26, H20. C16 is actually 16 and 16, 34. Yeah, 34 on a child. It should be 34, right? So C16H34, when going to break down, it will form what, Bacho? And C16H34 is going to be breakdown. One of the must product is C16H34 breakdown. One of the very perfect equation is that you are going to show the formation of 6 carbon alkene, and the rest of the molecule will be here, and it will be 10 carbon and 22 hydrogens, right, Bacho?
Yes.
Or even you can write like this. C6H12 and 12, and it is C4H10. It is also acceptable because C6H12 is over there, right, Bacho?
Yes.
Okay, so this is actually cracking that you need to understand. And cracking is very important because in our daily life, shorter hydrocarbons are more